Okay, now we're inside. This is going to be the air handler or indoor unit for the condensing unit outside that we've been talking about. So this is going to be the other half of the split unit. And all it is it's a metal housing. It's going to have an evaporator coil in it. And here's your suction line coming in, and here's your high pressure liquid line where it comes in. And right behind this fitting right here is going to be a small orifice. If I'm not mistaken, I think I put a orifice inside this one that's equal to 55 thousandths of an inch. That's going to be my metering device right there. That's what's going to spray the high pressure liquid refrigerant into the larger pipe, which is going to be in the evaporator. And I'm going to turn this unit off. It's going to have a breaker right here. This is it's a 30 amp, 240 volt, double pole, single throw breaker. And I'm going to cut it off. What that does is it cuts off all your control power for your unit, and neither unit will run now, indoor or outdoor. And I've taken the top off right here. I'm going to go over some of these components with you. Of course, all these right here is going to be your electric heating elements. It's going to be your emergency heat or strip heat. And you got some here and you got some over here too. And typically when you see a little thing like this right here, what that's going to be is it's a type of a bimetal thermal overload device. In other words, if it gets too hot inside here, in other words, if you ain't got good airflow through the unit itself, then this is going to get too hot and it's going to open the circuit, turn off your heaters. That keeps you from having a fire and stuff like that. It's a safety device. And got a little circuit board in here as well. It's going to control your indoor blower fan, stuff like that. Right down in here, that little device right there is going to be that device right down there. What that's going to be is a heat sequencer. It's kind of like a thermal overload, except it's going to make up when it gets to a certain temperature. And what that does is it lets your heaters come on, and it delays your fan from coming on. So your heater's going to come on first, heat the ductwork up real nice and cozy, and then it's going to make up and then bring on your airflow. So that way you get hot air out of the vents right when the fan comes on. Okay. And that down there is going to be a control transformer. That's going to make your 24 volts AC that energizes all your coils for your relays and contactors, and also it's going to supply your thermostat with the control voltage it needs to turn everything on like it needs to. And for reference, I've got here's a transformer right here. I've got a replacement. I try to buy a few spare parts because you never know when you're going to need one, and if it's on a weekend it's hard to get somebody to open up to sell you one. But what this is right here, you see on top, it's got this terminal and then the other one over here. That's where you're going to connect your 240 volts AC to. And down here at the bottom, it's going to give you 24 volts AC from here to here. There's two separate windings inside this. They're completely isolated from each other. They are. It's an induced voltage from one side to the other. And this is a 40 VA, or volt amperes. Basically, it's a step-down transformer, and it's going to take 240 volts AC and put it through here, and then create a much lower voltage, 24, so that you can use it for your controls. And just as a reference, this is the ratio between this winding and this winding is going to be 10 to 1. This little fella right here, if it goes out, you got nothing, because all your controls that kick on your compressor and your fans and everything is supplied by 24 volts AC, and here's where it's made right here.